I'm Reverend Greg and I welcome you to this video on blend modes, surface alpha and premultiplying alpha. Ever had trouble drawing multiple sprites and strings to a surface and realized somehow the alpha is all messed up? Like if this is what you wanted and this is what you got? This video will explain why and what you can do about it, with and without the shader. I recommend reading the Yo-Yo Games tech blog explaining blend modes part 1 and part 2 by Mark Alexander linked in the description of this video, but I'll try to recap the topic before moving on to showing possible solutions. Let's talk about blend modes first. This is the GPU drawing pipeline I already showed in the very first video of the shader tutorial series. Everything we draw passes these stages: vertex and geometry shader, some projection stuff, the fragment shader, several tests, and in the end, the blending stage. This is where the pixels we draw are blended with the pixels of the render target we're drawing to, so a surface or the back buffer. GameMaker Studio gives us control over this stage with the blend mode functions. When we, in example, set the blend mode BM_add, we're just sending instructions to the GPU to add up the RGBA values of both pixels and draw the result to the target. This also means if you had trouble with the surface as alpha, then that's not GameMaker Studio's fault. It's just how GPUs work. So let's have a look at how these blend modes work. Let's say we're drawing this orange circle sprite onto this blue surface. The orange circle sprite we're going to draw is called the source, and the blue surface we're drawing upon is called the destination. The circle sprite has two colors. The circle's orange RGBA is red 255 divided by 255, so 1, green 175 divided by 255, so about 0.69, blue 93 divided by 255, so about 0.36, and alpha 1. I'm dividing those RGBA colors by 255 because inside the GPU all colors range from 0 to 1 instead of the usual 0 to 255. And the color outside the circle is 0000, so a completely transparent black. The surface's blue's RGBA is about 0.27, 0.55, 0.8 and 1. Now let's see what happens if we blend those in the normal blend mode, which is the default setting in GMS. We could use the function GPU set blend mode and pass in the constant BM_normal, but that doesn't help explaining what happens. So instead, I'm going to use the extended function GPU set blend mode ext. In the GMS documentation on the function GPU set blend mode, you can see how the basic blend mode BM_normal is built. The source blend mode is BM source alpha, and the destination blend mode is BM inf source alpha. So GPU set blend mode BM_normal is the same as GPU set blend mode ext BM source alpha, BM inf source alpha. If you're using GMS1, by the way, just replace GPU with draw. And this is what the orange circle sprite and the blue surface would look like. Exactly what we expect it to be. But let me show you why by calculating the result of the blending stage. We'll just calculate the random orange opaque pixel on the inside of the circle and the random black transparent pixel on the outside. So we already know the normal blend mode is BM source alpha, BM inf source alpha. And we know BM source alpha is 4 times the same factor, source alpha, whereas BM inf source alpha is 4 times the same factor, source alpha inverted. And here's how the colors are blended. The resulting red value is the red value of the source pixel times the first factor of the source blend mode, which in this case is source alpha, plus the red value of the destination pixel multiplied by the first factor of the destination blend mode, which is source alpha inverted. So source red times source alpha plus destination red times inverted source alpha. The resulting green then is source green times source alpha plus destination green times inverted source alpha. The resulting blue is source blue times source alpha plus destination blue times inverted source alpha. And finally the resulting alpha is source alpha times source alpha plus destination alpha times inverted source alpha. This looks a bit complicated at first but gets better after a while. But now that we know how those blend factors are used to calculate the resulting color, we can finally calculate one random pixel inside the orange circle. We'll have to calculate the color component-wise. So source red 1 times source alpha 1 plus destination red 0.27 times inverted source alpha 0 results in a red 1. Now instead of calculating the remaining channels, we can just have a look at the pattern here. In blend mode normal, if the source pixel's alpha is 1, all source color channels are multiplied by 1, so they're unchanged. And all destination channels are multiplied by inverted source alpha, which is 0, so they're completely ignored. Therefore the resulting color is exactly the same as the source color, orange. Now let's look at the random pixel outside the orange circle. The source color there is black with alpha 0. And we can see right away what happens. All source channels are 0 multiplied by source alpha, which is 0 as well. So the source color at source alpha 0 is completely ignored. The destination color, however, is multiplied by the inverted source color, so by 1. So if the source alpha is 0, the result of blend mode normal is the destination color. It's very important that you understand this up to here, because it will get more complicated in the next step. So just watch this part again and do the maths along with the video if you had trouble understanding this so far. But on to the next step. What if the source image has alpha values between 0 and 1, like in this image? We'd expect the result to look like this, and if we draw the blue sprite and then the circle with the alpha gradient to the application surface, then that's what we would get. But if we draw the blue sprite to a normal surface and the circle with the alpha gradient to the same surface, then that surface would look like this. Although the surface is completely opaque after drawing the blue sprite, drawing the circle with the alpha gradient unexpectedly reduced the alpha of the surface. We can see the checker's background shining through now. This would actually happen with the application surface as well, by the way, but GameMaker Studio helps us out there by locking the alpha value to 1 on the application surface. But let's see why this happens. The reason is in the GPU's blending. First, let's pick a pixel where the source alpha is 0.8. In blend mode normal, this means all source channels are multiplied by 0.8 and all destination channels are multiplied by the inverse, so 0.2. Red, green and blue are linearly interpolated. 80% of the source channels plus 20% of the destination channels. That's all fine, but the resulting alpha is 80% of the source as well and 20% of the destination as well. So the result of 0.8 times 0.8 plus 1 times 0.2 is less than 1. It's 0.84. This means the surface alpha was reduced by blending from 1 to 0.84. And if we do the maths on a source pixel with an alpha value of 0.4, the result is even more obvious. While the linear interpolation of red, green and blue is what we'd expect, the interpolation of the alpha values reduces the surface alpha to 0.76 now. But if we pick pixels further to the right, the source alpha gets lower and lower, and at source alpha 0, the result would be the destination alpha as in the previous example, which is alpha 1. Again, make sure you understand this step before continuing with this video, because now we'll look at a different blend mode and we're going to use this later when showing solutions on how to fix the issue. Now in this example we'll use the same source sprite with the alpha gradient, but we'll use the blend mode BM1 BM_inf source alpha. The result will look like this. But to explain what happens, we'll have to do some maths again. The source blend mode is BM1. This means all source factors are just 1. So source red times 1, source green times 1, source blue times 1, and source alpha times 1. The destination blend mode is the same as before, inverted source alpha. So the larger the source alpha is, the lower the destination factor will be. If we pick a pixel at source alpha 0.8, the resulting color will be the source color, unmodified due to the source blend mode BM1, plus the destination color modified by the inverted source alpha. In this blend mode we can see pretty easily that the resulting RGB color can never be darker than the source color, since it's always source color times 1 plus something. In this example the result at source alpha 0.8 is a very bright yellow. Now if we pick a pixel at source alpha 0.1, this brightening is more obvious even. We're adding up 100% of the source color and 90% of the destination color. The result is pure white, since now red, green and blue are all at 1 or above. But why is the circle chipped on the right side? According to this blend mode it should be pure white. The reason this time is not in the GPU, it's in the way the source sprite is saved. When you save a PNG image, most software try to save space by setting all fully transparent pixels to black. So what happened here is once the circle sprite reaches alpha 0, the RGB is not orange anymore, it's black. And in this blend mode, the resulting color is the destination color if the source color is black with alpha 0. I'll leave a link to this image in the description of this video if you want to look at it later again as some kind of reference on how blend modes work. But now it's time to fix the alpha issue we've encountered in the second example. I'm going to switch to a GameMaker Studio 2 project I've prepared for this tutorial. You can download it by a link in the description of this video as well, but if you're using GMS1 still, this video should help a lot already even without the project file. I'm going to show 7 demo objects with these results. First a reference to explain what we're doing, then the version with the alpha issue, then a first simple solution with a different source, and a second simple solution with locking the alpha channel, then a step towards the final solution, a partial solution if you don't need fonts, and at last a final solution which works with fonts as well, but needs a simple shader. So let's see what we're working with. We're going to use these sprites, a checker's background, a space background sprite, a glowing ring, a glowing text, then for one of the simple solutions another ring sprite and another text sprite, and for the partial solution near the end the glowing ring with premultiplied alpha and the glowing text with premultiplied alpha as well. We also got two fonts, one with and one without anti-aliasing. Then we got one demo object for each of the steps shown before with just a draw event, and a controller object which on pressing space activates one of the demo objects and deactivates all others. And in the room we just got the orange checkers background and in an instance layer all the demo objects and the controller, so the objects are always drawing on top of the checkers. There are also some resources labeled tutorial. Those are resources used in the introduction of this video if you want to have a closer look at them. Now I'm just going to open all draw events of the demo objects and go through them one by one. Version 0, the reference. This is just drawing everything to the application surface. The space sprite, the glowing ring logo sprite, the glowing supernova text sprite, and finally the anti-aliased font reading press enter to start. And this is what it looks like. The checkers background is covered by the space sprite, and then the ring logo, the supernova text and the font are drawn on top of that. So far so good. Now let's have a look at version 1, the one with the alpha issue. Here we're creating a surface, set it as render target and clear it to black 0. Then we draw the space sprite on it, and the glowing ring logo, then the glowing supernova text and the anti-aliased font. After that we reset the render target and draw the surface. As we know by now, this can't be the same as the reference. By the way, in this demo project we can overlay the reference by pressing the Alt key. By pressing enter we can zoom in, and with the arrow keys we can pan the zoom. We can easily see that the glows of the ring and the supernova text sprites are reducing the alpha of the surface. But if we look closely at the font we can see it there too. The font is anti-aliased, which means it has alpha values between 0 and 1 around its border. And those pixels reduce the alpha of the surface, which is why we can see the orange checkers background shine through the surface. Now the first simple fix. We know this problem only occurs when alpha values are between 0 or 1, but not when the alpha values are either 0 or 1. So the first simple fix, of course, is only using sprites with alpha values of 0 or 1. That's why I added those two sprites. This golden ring only has an alpha value of 0 or 1, and so does the golden supernova text sprite. Also, one font resource is without anti-aliasing and thus has a clean alpha cut as well. The code is exactly the same as in the last version, I only swapped the sprites and the font. We're creating, setting and clearing the surface, draw the space sprite, draw the golden ring logo, draw the golden text, draw the font but without anti-aliasing, and then reset and draw the surface. And this is what it looks like. Since there are no alpha values other than 0 and 1, this works as intended. The surface stayed completely opaque. But of course you can only use this fix if you don't need partial transparency and if the GPU's texture interpolation is turned off, for example in pixel art. Now version 3 will add some lines of code, but it will work with the original glowing sprites. We'll start the same way again, creating, setting and clearing the surface and drawing the space sprite. But this time before drawing the glowing ring sprite to the surface we will lock the alpha channel. This means the blend mode will still take the alpha value of the source and the destination to calculate the RGB values of the result, but the GPU now can't change the surface as alpha anymore. Since after drawing the space sprite to the surface, that surface was completely opaque, this means after drawing the other sprites, the surface will still be opaque. So after locking the alpha channel, we'll draw the glowing ring sprite, the glowing supernova text and the anti-aliased font. Then we can unlock the alpha channel again, reset the surface and draw the surface. And this is the result. It looks exactly the same as the reference. I'm pressing Alt over and over again to overlay the reference and there's no visible difference at all. Now this works if the first thing you draw onto the surface is filling the surface and is opaque. But let's have a look at what happens if the first sprite is not filling the surface or is not opaque. In version 4 we're doing nearly the same as in version 3. The only difference is that we don't draw the space sprite and that we lock the alpha after drawing the glowing ring sprite. So again we're creating, setting and clearing the surface, then skip the space sprite, draw the glowing ring sprite and lock the alpha channel afterwards. Then drawing the glowing supernova sprite, the anti-aliased font, and in the end again unlock the alpha channel, reset the render target and draw the surface. You can probably already guess what's going to happen now. We drew the glowing ring to the surface and then locked the alpha. So everything drawing on top now couldn't change the alpha of the surface anymore. Now while this is a useful technique to mask sprites, it's not what I was going for. I want to assemble the ring, the text sprite and the font on a cleared surface instead. Now in version 5, it starts to get a bit more complicated. Let's just draw everything in the second blend mode we looked at in the introduction. The source blend mode was BM1 and the destination blend mode was BM_inf_source alpha. So we're creating, setting and clearing the surface and then set blend mode X to BM1, BM_inf_source alpha. We still skip the space sprite of course, and then draw the glowing ring, the glowing supernova text sprite and the font. Notice I didn't lock the transparency like in the last version, we won't need to in this example. After drawing the font, we can reset the render target, draw the surface still in extended blend mode, and after that reset the blend mode to BM normal again. We already saw what happens in this blend mode and no, it's not going to work as it is right now, but let's have a look anyways. We can observe pretty much what we saw in the first part of this video. Where the source sprites have alpha 1, everything looks great, but as soon as the alpha value drops, everything gets brighter and brighter. So we need to find a way to lower the brightness depending on the alpha value. And that's where premultiplying alpha values comes in. The idea of premultiplying alpha is really simple. Multiply the RGB values of a pixel with the alpha value of that pixel. So the lower the alpha is, the darker the RGB color gets. Let's say this is the original sprite. Just a stupid cyan pink wave with an alpha gradient. And this is what it would look like if there would be no alpha channel. Then this would be the version with premultiplied alpha. The alpha value is multiplied into the RGB values. So the lower the alpha gets, the darker the color is. At alpha 0, the color will be black and fully transparent. For demonstration purposes, let me remove the alpha channel here as well, and we'll easily see what this means. As you can see, the color gets darker and darker until it reaches black at alpha 0. This should fix our problem from before where everything got brighter and brighter with low alpha values on the source sprite. So back in the project, I made 2 copies of the glowing ring sprite and the glowing supernova sprite and added prem_a for premultiplied alpha to the resource names. Looking at both, you'll notice that the lower the alpha gets, the darker the colors become. Fortunately, we don't have to do anything complicated to premultiply the alpha. In GMAS 2, we can just toggle this checkbox here, and in GMAS 1 there's a button somewhere on top of the sprite editor, but if I remember correctly, it's not toggleable, so we can't go back to the original. Now back in our code, all we need to do is use those 2 sprites with premultiplied alpha instead of the original sprites. And now it looks much better already. The 2 sprites are fixed. Unfortunately, as of now, we don't have a premultiply alpha button in the font editor, and thus the font still won't work. But if you don't need to draw a font to the surface, this is your solution already. And if you do use a font and don't want to use a shader, you could create your own sprite font and premultiply the alpha of the sprite font to make this work. But now to the last version. Here we'll use the original sprites again instead of the ones with premultiplied alpha, because this time we're going to use a shader to premultiply. This code again is nearly the same as before, with the only difference of setting the shader to draw everything to the surface and resetting the shader before drawing the surface to the application surface. So we're creating, setting and clearing the surface once more, setting the extended blend mode BM1, BM_inf_source alpha, and setting the shader to premultiply the alpha. We'll have a look at the shader code in a second. Now through the shader we'll draw the glowing ring sprite, the supernova text sprite and the anti-aliased font. After that we'll reset the render target, reset the shader, draw the surface, and in the end reset the blend mode to BM normal again. The shader code is really simple. The vertex shader is a simple pass-through shader, and this is the fragment shader. All we're doing here is getting the pixel RGBA color, multiply it by the interpolated vertex color, and setting the fragments color RGBA to red times alpha, green times alpha, blue times alpha, and just alpha. Now of course if you'd need another shader at the same time, in example if you're using a distortion shader or an aberration shader, you'd have to do the premultiplication in there. That's really simple to do, but if you don't know enough about shaders you might want to watch my shader tutorial series linked in the description of this video. But now let's see what this code looks like in action. This is what I wanted. The glowing ring, the supernova text and the font are assembled on a surface, and as long as the surface is drawn in blend mode BM1, BM_inf_source alpha, the result will look right. I hope you enjoyed this video and understand blend modes and surfaces a bit better now. No more wondering about why a surface's alpha is messed up when drawing upon it, and no more headbutting your keyboard trying to figure out the solution. This video showed you 3 ways to fix this. Until next time.